Is your SQL query taking too long to run? Slow queries can impact your application's performance and user experience. In this video, I will show you practical ways to optimize your SQL queries for faster execution. Let us get started. SQL databases power millions of applications, from small websites to enterprise solutions. A poorly optimized query can slow down an entire system. That's why learning SQL performance tuning is crucial. Let us start with the indexing. An index is like a book's table of contents. Instead of searching the entire database, an index helps SQL find the right data quickly. Let us see an example. Without an index, SQL scans the entire table. With an index, it finds the data instantly. Now, let us move on to optimizing SQL joins. Joins combine data from multiple tables but can be slow if not optimized. The key is to index the column used in the join condition. Let us see an example. By creating an index on customer ID, we speed up the join process significantly. Now, let us analyze execution plans. Execution plans are like a road map of how SQL executes your query. They help you find performance issues and optimize queries accordingly. By checking the execution plan, we can identify slow operations and optimize them. Next, let us go over some bonus tips for query optimization. Here are some additional tips. Always specify column names instead of using select star. Avoid functions inside, where, and use indexing smartly. Now, let us wrap up. To summarize, indexing is essential for fast queries. Joins should be optimized, and execution plans help diagnose slow performance. If you found this useful, don't forget to like, subscribe, and comment below with your SQL performance challenges. Joins are one of the most important concepts in SQL. If you have ever struggled to understand the different types of joins, this video will clear up all your doubts. Today, I will explain inner join, left join, right join, full join, and self join with practical examples. Let us get started. SQL joins help combine data from different tables to get meaningful insights. They are widely used in reporting, data analysis, and database management. Let us start with the inner join. Inner join is the most commonly used join in SQL. It returns only the rows where there is a match in both tables. Let us look at an example. Here is an example. We have two tables, customers and orders. The inner join only returns customers who have placed an order. Now, let us move on to the left join. Left join returns all records from the left table and only matching records from the right table. If there is no match, it fills the columns from the right table with null values. Let us see an example. Notice that Alex Brown has no orders, but he still appears in the result with a null value for order ID. This is how left join works. Next, let us look at right join. Right join, the opposite of left join, it returns all records from the right table and only matching records from the left table. Let us see an example. Full join combines data from both tables. It includes unmatched records from both sides, filling missing values with nulls. Next, let us discuss self-join. Self-join is used when you need to compare rows in the same table, such as finding managers of employees in an organization. To summarize, inner join is the most common. Left and right join include unmatched records. Full join combines all data. And self join is useful for hierarchical data. Let us wrap up. Have you ever needed to rank data, calculating running totals, or compare rows in SQL? That is where window functions come in. In this video, I will explain SQL window functions like row number, rank, lead, and lag with practical examples. Let us get started. SQL window functions allow you to perform calculations across a specific set of rows called a window. Unlike a group by, they return individual rows while adding extra calculations. Let us see an example. The syntax for window function is simple. You can use over with optional partition by to divide data into groups and order by to control ranking or calculations. Row number assigns a unique number to each row within a partition. This is useful when you need to remove duplicates or implement pagination. Rank assign the same rank for duplicate values but skips numbers for the next rank. Let us compare it with the dense rank. Dense rank works like rank, but it doesn't skip numbers. If you need consecutive ranking, use this function instead. Lead helps compare a row with next row. For example, in sales data, you can check the next month's revenue. Lag works like it leads but moves backward. It is useful for comparing values with the previous row. Sum with the over calculates a running total without grouping the results. It is commonly used in financial reports. A moving average helps smooth out functions in data. This is useful in stock market analysis and forecasting trends. You can combine multiple window functions in a single query for advanced analysis. This example shows how to assign row numbers, ranks, and fetch the next salary value. To summarize, window functions are powerful tools for ranking, comparisons, and cumulative calculations. Use them to optimize your SQL queries efficiently. I hope this video helped you understand SQL window functions. Comment below. Don't forget to like, subscribe and check out my next video on advanced SQL optimization techniques. Have you ever wondered why some SQL queries take forever to run while others execute instantly? In this video, I will show you how to optimize SQL queries for maximum performance. We will cover indexing, query execution plans, caching, and best practices. Let us get started. Optimizing SQL queries is essential for fast applications, reducing database load, and ensuring a smooth user experience. Let us start with indexing. Indexes improve performance by reducing the number of rows scanned. Think of an index as the table of contents in a book. It helps to locate information quickly. A clustered index sorts and stores data physically, while a non-clustered index creates a pointer to the data. You can have multiple non-clustered indexes but only one clustered index per table. Avoid functions on indexed columns inside where clauses. Instead of year of order date equal 2024, use a range filter to allow index usage. A query execution plan shows how SQL retrieves data. It helps identify performance issues like full table scans or missing indexes. Avoid select star unless absolutely necessary. Fetch only columns you need to reduce data transfer and improve performance. Using exists instead of in is more efficient in large data sets because it stops execution once a match is found. Caching improves performance by reducing database queries. Consider using Redis or memcached for frequently accessed data. To summarize, always use indexes effectively, avoid unnecessary data retrieval, optimize joins, and leverage caching for high-performance SQL queries. I hope this video helped you understand SQL query optimization. Give comments. Don't forget to like, subscribe, and check out my next video on SQL transaction. Ever wondered how databases ensure data integrity even when multiple users update records at the same time? In this video, we will dive into SQL transactions, isolation levels, and how databases handle concurrent operations safely. Let us get started. A transaction is a group of SQL statements that must succeed or fail as a unit. If any statement fails, we roll back the transaction to maintain data integrity. SQL transactions follow ACID properties. Atomicity ensures all operations succeed or fail together. Consistency keeps data valid. Isolation prevents conflicts and durability guarantee changes persist. Commit permanently saves changes while rollback undo them if something goes wrong. Always use transactions when dealing with the critical updates. When multiple transactions run at the same time, issues like dirty reads, non-repeatable reads, and phantom reads can occur. SQL isolation levels help prevent these problems. SQL provides 4 isolation levels to control how transactions interact. Let us explore each level in detail. Read uncommitted is the least strict isolation level. It allows transactions to read uncommitted changes which can cause incorrect results. Read committed prevents dirty reads by ensuring that transactions only see committed changes. This is the default isolation level in most datasets. Repeatable read ensures that if a transaction reads a value once, it will see the same value if it reads it again, even if other transactions modify the data. Serializable is the strictest isolation level. It looks the data set to ensure complete transaction isolation, but it can slow down performance. Choosing the right isolation level depends on your application. Use read committed for general use, repeatable read for finance, and serializable for highly secure transactions. To summarize, transactions maintain data integrity, asset properties ensure reliability, and choosing the right isolation level prevents concurrency issues. I hope this video helped you understand SQL transactions and isolation levels. Comment below. Don't forget to like, subscribe, and check out my next video on SQL deadlocks.